Welcome. Tonight, we sift through the evidence of a 4-billion-year-old crime scene. We are listening for the moments when the pulse of this planet suddenly stopped, leaving only silence. The fossil record is not a continuous story of evolution. It is a violent, interrupted epic, a book where entire critical chapters have been mysteriously torn out. We all know the story of the one great catastrophe, the asteroid that ended the dinosaurs. But that was only the last chapter. In our planet's immense history, life has been pushed to the absolute brink at least 5 distinct times. We call them the Big Five, and for most of them there is no asteroid, no simple impact crater, no single obvious culprit. We are here to explore the great filters, to investigate the unsolved mysteries of prehistoric mass extinctions. We will explore the planet's first poisoning, when life itself created a toxin that suffocated the globe. We will stand in the silent ghost world left behind by the Great Dying, an event so severe it nearly sterilized the Earth. We will examine the subtle, conflicting clues, the suffocating oceans, the colossal volcanic floods, the sudden deep freezes, and ask the question that echoes through time. What caused these silences, and what does it take to survive them? So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who is joining us from around the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Our investigation begins not with a sound, but with its absence. To understand the scale of this mystery, you must first let go of the map of time that lives in your head. Our human story, our cities, our wars, our entire written history is a thin, fresh layer of paint on a very, very old canvas. We are looking deeper. We are looking into deep time. This is a concept so vast it is almost impossible for the human mind to hold. If you were to stretch your arms wide to represent the entire 4.5 billion year history of our planet, all of human civilization would be erased by a single pass of a nail file across your fingertip. We are searching for events in that vastness. We are looking for killers that stalked the Earth hundreds of millions of years before that fingertip even existed. What evidence could possibly survive such an abyss of time? There are no witnesses. There are no written accounts. All we have are the fossils. This is our only evidence, and it is profoundly, deeply, and beautifully incomplete. A fossil is not a record, it is a miracle. It is the result of a 1 in a billion chance. An organism must die in the right place, at the right time. It must be buried quickly by the right kind of mud, safe from scavengers. It must lie undisturbed for millions of years while its bones are slowly, molecule by molecule, turned to stone. Every fossil we hold is a lottery ticket that won. What this means is that our 4-billion-year-old crime scene is a library where 99.9% of the books have been burned. We are left to piece together the entire story of life from a few scattered, charred pages. We find layers of rock, and in one layer, there is an entire world, trilobites, corals, a rich and complex ocean. Then, in the layer of rock just above it, there is nothing, a blank page, a layer of stone and silence. This is the fingerprint of a mass extinction. It is the evidence of the silence itself. We are not looking at a photograph of the crime. We are looking at the shadow it cast. Our job is to use these few faint, fragile clues, these whispers in the stone, to reconstruct the killer. And the first, most ancient of these silences was not an accident. It was an execution carried out by life itself. Before we step into that first blank page, we must understand one crucial distinction. Death is not the enemy of life. It is the engine. In the 4-billion-year history of this planet, the vast majority of all species that have ever existed are now extinct. This is not a sign of failure. It is the normal, steady pulse of evolution. We call it background extinction. It is the constant, quiet turnover of the living world. A species evolves, it lives its life for a few million years, and then, slowly, it is outcompeted by a new, more efficient design. It is the natural cost of living, the price of adaptation. It is a local tragedy, but it is not a global crisis. This is not what we are investigating. We are hunting for something else entirely. We are looking for the moments when the pulse of life does not just flicker, but stops. A mass extinction is not a turnover. It is a global, systemic collapse. It is the difference between a forest losing a single old tree and the entire forest burning to the ground in an afternoon. A background extinction is a test of specialization. A mass extinction is a test of survival. Suddenly, the rules that guaranteed success for millions of years, speed, strength, size, efficiency, become meaningless. When the sky goes dark or the oceans turn to acid, these advantages become liabilities. This is the true nature of a great filter. It is not a simple disaster, it is an evolutionary bottleneck, a brutal, indiscriminate sieve that shakes the entire tree of life, and only a few, often unpredictable, survivors manage to cling on. It is a global crisis that changes the rules of the game forever, and when the dust settles, the few survivors find themselves in an empty world, a blank canvas, ready to begin a new age. Our journey begins with the very first of these great filters, the first time the planet truly tried to sterilize itself. It is a story not of rocks falling from the sky, but of a poison rising from the water, a poison that life itself had invented. Let us journey back to a world you would not recognize, an alien planet that is our own 2.5 billion years ago. The air has no breathable oxygen. The sky is a hazy reddish-orange, thick with methane. The oceans are not blue, they are a murky greenish-brown, rich with dissolved iron. This world is not empty, it is dominated by life, a sprawling, invisible and ancient kingdom of anaerobic cells, life that thrives in the absence of oxygen. For over 1 billion years, this was the unchallenged, stable and silent reality. Then, a new kind of cell emerged in those green oceans, cyanobacteria. It had discovered a miracle, photosynthesis. It had learned how to eat the sun. This new metabolic engine was a revolution, and it was wildly successful. But it had a byproduct, a waste gas, a chemical exhaust that this new bacteria expelled into the water. This waste gas was oxygen. To the established, dominant anaerobic life, this new gas was not life-giving. It was a corrosive, violent, and agonizing poison, a chemical fire that tore their delicate cells apart. For millions of years, the oceans fought back. The dissolved iron captured this new poison, rusted, and sank to the seafloor, forming the vast iron-banded formations we mine today. But eventually, the iron ran out. The buffer was gone. The oxygen, now with nowhere to go, flooded the water and began to pour into the atmosphere for the first time. For the anaerobic world, this was the apocalypse. The planet's first great mass extinction was a case of accidental, planetary-scale self-poisoning. Life, in its search for a new source of energy, had suffocated itself. But this poison had a second, unintended consequence. As it filled the sky, it reacted with the methane, the very gas that kept the planet warm. The greenhouse blanket was torn away. The world, having survived its first great poisoning, was now plunged into its first great chill. The planet had survived its chemical crisis, but now it faced a physical one. The greenhouse was broken, the Earth's thermostat was shattered, and the planet began to freeze. This was not a gentle ice age. This was the Cryogenian period, a deep, profound and global winter that lasted for millions of years. The ice caps, once confined to the poles, began to creep outward. They advanced relentlessly, swallowing the continents, reflecting more and more of the sun's warmth back into space. This feedback loop, this runaway ice, did not stop until the entire planet was entombed. This was Snowball Earth. Imagine it, a world almost entirely white. The oceans were not liquid, they were a solid, cracked sheet of ice, perhaps a kilometer thick. The land, silent. The only sound, the howl of a dry, sterile wind blowing over a landscape of endless ice. This was a planet frozen in a deep, white silence. The mystery of this filter is not just what caused it, but how anything survived it. For tens of millions of years, life was trapped beneath a ceiling of solid ice, or perhaps clinging to tiny, sun-warmed patches of slush near the equator. This was the planet's first, most brutal filter. It was a test of pure endurance. But the even greater mystery is, what ended it? How does a planet escape a perfect, heat-reflecting white prison? The answer came, as it so often does, from within. The planet was frozen, but it was not dead. Volcanoes. For millions of years beneath the ice, volcanoes continued to erupt. They pumped carbon dioxide into the atmosphere. With no rain to wash it away and no oceans to absorb it, the gas slowly, patiently accumulated. It was building a new greenhouse blanket, molecule by molecule. After millions of years of this slow, patient accumulation, a tipping point was reached. The planet began to thaw, not gently, but catastrophically. The great white silence was broken, and life, the few hardy survivors that had clung on in the dark, found themselves in a new, warmer, and very different world. This great melt, this release, set the stage for life's next great experiment. A new, strange, and beautiful garden was about to grow. The great ice had retreated. The oceans were liquid and warm. And in this new post-snowball world, life began a new experiment. For the first time on this planet, life became large. This was the Ediacaran period, and the life that filled its seas was not like anything we know today. This was life before the blueprint of the modern animal had been invented. Imagine a shallow, sunlit seafloor. It is covered not with corals or fish, but with a strange, silent and soft-bodied garden. There are creatures shaped like quilted mattresses, lying flat on the sand. Others look like fronds, leafy and anchored, but they are not plants. Others are discs. None of them have mouths. None of them have guts. None of them have shells or teeth or claws. For millions of years, this was the dominant reality. It was a world, perhaps, without predators. A slow, peaceful and alien world where life simply was, absorbing nutrients from the water, sitting in the sun. And then, in the fossil record, they vanish. This strange garden of quilted, leafy creatures is gone. It is another blank page, another silence. This is our first great unsolved mystery. What happened to this first experiment in large-scale life? Were they the victims of another environmental shift? Did the ocean chemistry change, suffocating their simple, soft bodies? Or was it something new? Was it the arrival of a new, more violent kind of life? Just as the Ediacaran fossils disappear, the rock layers above them explode with something new, the Cambrian explosion. This is the arrival of our world, the sudden appearance of animals with shells, animals with legs, animals with eyes, and animals with mouths. The unsolved question is, was the Ediacara garden a victim of the first Big Five extinction, or was it simply eaten? Was this peaceful, silent world, this first experiment, simply pushed aside or consumed by the new, more complex and far more brutal world of the predator? Whatever the cause, the garden was closed. The first draft of complex life was torn up, and the new world, this Cambrian world of hunters and hunted, was about to face its own set of filters. The age of the Big Five had begun. The Cambrian world had set the new rules. Life was now a game of eat or be eaten, and for the next 100 million years, life exploded in a frenzy of creativity. This brings us to the Ordovician period. This was not a quiet, empty world. It was a paradise. The globe was a tropical hothouse. The continents were clustered in the warm southern latitudes, and the oceans were vast, shallow, and teeming. Life had diversified into a spectacular menagerie. Trilobites, the armored kings of the seafloor, were at their absolute peak. The first great coral reefs were being built, and towering, straight-shelled nautiloids, ancient squid-like predators the size of a telephone pole, patrolled the waters. This was the Great Ordovician biodiversification. Life was stable, it was complex, it was successful, and then it died. This was the first of the Big Five. It was not a slow decline like the one that choked the Devonian. It was a sudden, violent 1-2 punch. The weapon was not fire, it was ice. In a geological instant, the hothouse planet plunged into a deep freeze. A massive, sudden, and brutally short ice age gripped the globe. Sea levels plummeted as the water was locked up into glaciers. The vast, shallow, tropical seas that had been the cradle of life simply vanished, draining away and exposing entire ecosystems to the air. Life had nowhere to go. The casualties were catastrophic. 85% of all species in the ocean were wiped out. It was the first great filter of the modern animal world. But when we look at this crime scene, the motive is missing. The killer is obvious. It was ice. But the mystery is the trigger. What force could possibly cause a warm, stable, tropical paradise to spontaneously freeze over? This is one of the coldest cases in our planet's history. The trigger for the Ordovician freeze remains one of the great who'd units of deep time. The usual suspects do not fit the crime. Normally, to chill a planet, you need to remove its carbon dioxide. We look for evidence of vast new mountain ranges being born, like the Himalayas, whose fresh rock pulls CO2 from the air. We find none. We look for a change in volcanoes, but volcanoes typically warm the planet. A massive eruption can cause a volcanic winter, but it is a short-lived temporary event. This was a true, sustained ice age. The Earth-based evidence is weak. The clues do not add up. This lack of a terrestrial culprit has forced some scientists to look for an answer not on our planet, but far, far beyond it. It is a chilling and exotic hypothesis that this extinction was caused by a cosmic assassination. The suspect is a gamma-ray burst, or GRB. This is the death scream of a star. When certain massive stars collapse, they can, for a few brief seconds, unleash a focused, hyper-concentrated jet of pure energy, a beam of gamma radiation that outshines an entire galaxy. If such a beam, from a dying star perhaps 6,000 light-years away, were to strike our planet, we would not see it, we would not hear it, but its effects would be immediate and catastrophic. The beam would strike the upper atmosphere, shattering the molecules of our ozone layer, instantly destroying our planet's shield against solar radiation. Life on the surface of the water would be scorched, but the greater damage would be chemical. The energized atmosphere would form nitric oxide smog, blocking the sun and plunging the planet into a cosmic winter. It is a theory, a dark, compelling, and spectacular one. It fits the evidence, a sudden, inexplicable freeze, a bullet from space with no fingerprints. But it remains a ghost. There is no crater, no lingering radiation. There is only the sudden silence in the rock and the mystery. The Ordovician was a sudden, violent chill, a cosmic shot in the dark. Life, however, is not so easily erased. It is resilient. The survivors of that great filter, the few hardy species that clung to life in the warmer, deeper waters, inherited an empty, quiet ocean. And in that silence, they began to build again. They rebuilt the world, and they built it into something formidable. This new age was the Devonian. We call it the Age of Fishes, but that simple name fails to capture the sheer, brutal creativity of this world. This was not the simple ocean of the Cambrian. This was a complex, competitive, and thriving metropolis. It was an age of biological armor, an arms race of shields and jaws. The undisputed kings of this dynasty were the placoderms, armored, terrifying vertebrates, And the king of kings was Dunkleosteus. This was not a fish as we know it. It was a 30-foot living tank. Its head was a fortress of solid, interlocking bone plates, and its mouth held no teeth. It possessed something far more terrifying: two massive, internal, self-sharpening blades of bone that snapped shut like a pair of hydraulic shears, with a force that could bite a modern shark in half. Alongside this predator, the first great reefs were being built, not by the corals we know, but by ancient sponges and microbes, forming structures so vast they dwarfed our own Great Barrier Reef. The seas were loud, complex, competitive, and stable. And then the light began to fade. This is the second of the big 5 extinctions, and it is perhaps the most unsettling of all. This was not a sudden catastrophe. There was no impact. There was no cosmic beam from a dying star. This was a twilight, a slow, creeping sickness that unfolded over millions of years. It was a dimming of the planet's vitality, a slow, planetary suffocation. We see it in the fossil record not as a single clean break, but as a series of terrible, shuddering breaths. A wave of extinction, followed by a brief, hopeful recovery, only to be followed by another, deeper and more final wave. Again and again the planet tried to heal, and again the sickness returned, each time taking more. And this sickness was not a random plague. It was a selective assassin. It targeted the most complex, the most advanced, and the most magnificent life forms. The great, sprawling reefs, the vibrant cities of the ocean were the first to go. They died, and the vast, vibrant structures they built vanished, leaving only stone. And the giant armored fish, the Dunkleosteus, the very kings of the ocean, were wiped from the earth. Their entire dynasty, that perfect, terrifying experiment in armor and power, ended not with a roar, but with a silent, suffocating gasp. They would never return. When we, the detectives of this 4-billion-year-old crime, examine the stone from this period, we find the killer's fingerprint. There is no impact crater. There is no layer of ice-rafted debris. We find a different, more subtle, and far more unsettling clue. The rocks that should be grey or tan are instead black. Deep, oily and sulphurous black shales, the colour of a dead, stagnant and poisoned bottom. Those black rocks are not just stones, they are a warning, they are a tombstone, and they are the key to the entire mystery. In a healthy ocean, when a creature dies, it sinks to the bottom and is consumed. Bacteria, scavengers, the entire invisible recycling system of the planet breaks it down, and this process uses oxygen. But if a rock layer is black, it means that organic matter, the soft bodies of plankton and algae, was not eaten. It was simply buried, intact. This tells us one chilling fact. The bacteria were not there. They could not live because the very bottom of the world had run out of breath. The weapon that killed the Devonian world was not a sudden impact. It was anoxia, a slow, creeping and planetary scale suffocation. The oceans, the very cradle of life, began to stagnate. The normal, healthy circulation that brought oxygen-rich surface water to the deep and nutrient-rich deep water to the surface simply stopped. First, the bottom layers of the ocean died and turned into a thick, toxic, and oxygen-free soup. Then, this layer of death began to rise. Imagine a living creature, a Dunkleosteus, swimming in the warm surface waters. Below it, the ocean is not a refuge. It is a rising wall of poison. This invisible ceiling of suffocation crept upwards over thousands of years, forcing all of life into an increasingly shallow, shrinking, and desperate layer near the surface. This is what killed the great reefs. They were suffocated from below. This is what killed the giant fish. It did not matter how strong their armor was. It did not matter how powerful their jaws were. They could not fight a chemical. They could not bite the water itself. They were trapped. They ran out of room. They ran out of air. This is the weapon. We have found the kill mechanism. But this only deepens the mystery and leads to the true, unsolved question. What could possibly cause the entire planet's oceans to stop breathing? What force could be so powerful that it could suffocate a world? The investigators of this crime scene have found a suspect, and the suspect is not in the ocean at all. It is on the land. The suspect at first seems impossible. It is not a volcano. It is not an asteroid. The suspect is the forest. For the first time in our planet's history, the land was turning green. After billions of years of being nothing but sterile rock and dust, life was finally climbing ashore. This was the age of the first great trees, like Archaeopteris, a plant that was neither fern nor conifer, but something new. These new organisms were not just simple mosses clinging to damp stone. They had invented a revolutionary and deeply destructive new technology. They had invented roots, deep, powerful, and persistent roots. These roots were a chemical and physical assault on the planet's surface. For the first time, life was not just sitting on the rock, it was actively tearing it apart. Tiny, relentless miners shattering the ancient stone, prying it open, and using acids to pull out the minerals that had been locked away for eons. The planet's entire geological savings account was being liquidated. This process unleashed a torrent, a flood of raw nutrients, phosphates, nitrates, a super fertilizer pouring from the rock into the soil and into the rivers. The planet's rivers, now running brown and thick with this new continental debris, carried it all into the sea. The ocean received this gift, and it choked. The algae and plankton in the surface waters, which had been limited by scarcity for millions of years, were suddenly handed an endless buffet. They exploded into a colossal, planet-spanning algal bloom, a green tide that turned the surface of the oceans into a thick, murky, and putrid soup. This was not the kill. The kill came later. The problem was what happened when this massive, choking layer of life died. It sank. This great rain of dead organic matter drifted down into the deep, dark water, and there, the bacteria feasted. It was a bacterial population explosion, and as these trillions of microbes consumed the dead algae, they breathed. They inhaled, using up all the available dissolved oxygen in the water. They suffocated the entire ocean from the bottom up. Life had once again, in its own creative and innocent search for success, become the planet's most efficient killer. The forests on land had suffocated the oceans. It was an act of unintended, planetary-scale matricide. This long, slow sickness set the stage for an even greater, more complete catastrophe, one that was waiting in the silence to come. Life had recovered again. The planet had endured the cosmic chill of the Ordovician. It had survived the long, suffocating twilight of the Devonian. Each time, the survivors had rebuilt the world from the ruins. And the world they built in the Permian period was perhaps the most complex, vibrant, and stable the Earth had ever known. On land, our own distant ancestors, the synapsids, the mammal-like reptiles, were the dominant force. Great sail-backed creatures like Dimetrodon ruled a world of tough conifer forests and sprawling deserts. The insects, the great survivors, had returned. The oceans were full. Life was good. The planet had found its balance. And then, the universe pulled the rug out. This is the third of the Big Five, and this is the one that matters. The Ordovician was a filter. The Devonian was a sickness. This was a planetary execution. We call it the End Permian Extinction, but that cold scientific name fails to capture the sheer horror of what happened. A more accurate name, the one that paleontologists whisper with a kind of dark reverence, is the Great Dying. This was not a filter that selected for the strong. This was a fire that burned the entire library. The statistics are numbing. They are so complete and so absolute that they cease to be numbers and become a void. In the oceans, an estimated 96% of all species vanished. Stop and think of that. Not 96% of creatures, but 96% of entire biological blueprints. The trilobites, who had survived for 250 million years and through 2 other mass extinctions, were gone. The great sea scorpions, gone. Entire forests of sea lilies vanished. The oceans fell silent, reduced back to a microbial sludge. On land, it was no better. 70% of all vertebrate life was wiped out. The great synapsid dynasties, our own ancestors, were all but erased. Even the insects, the great survivors of every other crisis, suffered their only known mass extinction in history. This was not a reset. This was game over. This was the closest life on this planet has ever come to being completely erased. The Earth was a morgue, a silent, empty globe covered in ash. When we look for the killer, there is no confusion. There is no subtle mystery, no exotic beam from space. This time we know exactly what did it. The killer was the planet itself. We have found the weapon, a continent-sized volcano, a wound in the Earth's crust so vast it bled fire for 1 million years. The weapon has a name, the Siberian traps. The word traps comes from the Swedish word for stairs, a term for the vast, stepped plateaus of lava this event left behind. It is a mundane name for the most violent act our planet has ever committed against itself. This was not a volcano. A volcano as we imagine it is a mountain, a conical peak like Vesuvius or St. Helens. It is a single, localized event that explodes, causes devastation, and then is over. This was not that. This was a wound, a vast, sprawling, open fissure in the planet's skin, where the Earth's crust had grown thin and the hot mantle was bleeding directly onto the surface. And it did not explode, it poured. Imagine a crack in the Earth opening up across what is now Siberia, stretching for thousands of kilometers. From this wound, a flood of basalt lava, a river of fire, begins to pour out. It is not a one-time event. It is continuous, relentless, and unstoppable. This river of fire floods the landscape, burying forests, boiling rivers, and turning entire continents into a black, glassy pavement of cooling rock. Then, a few thousand years later, the wound opens again. A new flood pours out, burying the first. And again, layer upon layer upon layer. This was not a catastrophe that lasted for an afternoon. It was a geological siege that may have lasted for 1 million years. The Siberian traps covered an area of 7 million square kilometers, larger than all of modern Europe. Enough magma poured out to cover the entire globe in a layer of rock 10 feet deep. It was the planet, in a slow, relentless fever, trying to turn itself inside out. And yet, for all this fire and molten rock, the lava was not the kill mechanism. The lava was a local problem. The true killer, the weapon that sterilized the oceans and suffocated the land, was not the fire at all. It was the breath of the fire. It was the gas. The lava was the spectacle. The true executioner was invisible. It was quiet. It was a gas, carbon dioxide. In the normal, healthy life of our planet, carbon dioxide is not a poison. It is essential, the planet's thermostat, a thin, gaseous blanket that traps just enough of the sun's warmth to keep the world from freezing. It is the gentle engine of a living climate. But the Siberian traps were not gentle. They were geological arson. For 1 million years, those open fissures in the Earth's crust pumped carbon dioxide into the air, not in small breaths, but in a choking, planetary-scale flood. The concentration of CO2 did not just rise, it exploded, perhaps reaching 10,000 parts per million. Our current atmosphere is just over 400. The planet's gentle blanket became a furnace. At first, the Earth's natural systems tried to fight back. The oceans, the great global carbon sink, tried to absorb the flood. They drank the CO2, pulling it from the air. But the oceans themselves were beginning to heat up, and this triggered the runaway. Warm water cannot hold dissolved gas. The oceans became warmer, so they absorbed less CO2. The less they absorbed, the more stayed in the air. The more stayed in the air, the warmer the planet became. The warmer the planet became, the warmer the oceans became. This was the feedback loop. The planet's emergency brake had failed and become an accelerator. The world was now in a full-blown runaway greenhouse effect. We must imagine this world. The air itself would have felt thick and heavy. Average global temperatures may have risen by 10, 15, or even 20 degrees. The heat was not a gentle warmth. It was a suffocating, damp weight from pole to pole. For the creatures on land, there was no escape. There was no shade, no night that offered relief. The great conifer forests, the base of the food chain, withered and died, turning the world into dry scrub. The great synapsid herds, our sail-backed ancestors, were not built for this. They were being slow-cooked in a global pressure cooker. This was the first kill mechanism. The planet had turned itself into an oven, but this suffocating heat was only the beginning. It was just the external symptom. The real engine of the 96% kill rate was happening in the water. The heat was the trigger. It was about to awaken a new, even more insidious killer from the depths. The land was an oven. The great conifer forests were tinder, and the animals were ghosts walking through blistering heat. But the true horror, the engine of the 96%, was happening in the water. The oceans had become unnaturally, lethally hot. Warm water cannot hold dissolved gas. It cannot hold oxygen. The oceans of the Permian, once vibrant and oxygen-rich, began to suffocate. This was a global cascade. The normal pulse of the planet, the great currents that pumped oxygen from the surface to the depths, faltered and stopped. The entire ocean became stagnant and dead. Imagine a glass of water left in the sun, rotting and turning foul. Now imagine that on a planetary scale. First, the deep ocean floor died and became an anoxic void. Then that layer of silent, suffocating death began to rise. It crept upwards from the abyss, a toxic, invisible wall, pushing all life into a thin, desperate layer near the surface. This was a bathtub where the drain was clogged and the poison was rising. But this new, hot, oxygen-free soup was not empty. Life always finds a way. As the oxygen vanished, a different, ancient, and more sinister form of life awakened, a kingdom of anaerobic bacteria. These were microbes that did not breathe oxygen, they were poisoned by it. They had been hiding in the dark mud for 1 billion years, waiting. Now, their world had come. Bacteria like Methanosarcina were the new kings. They saw a hot, dead, organic, rich soup and called it paradise. They began to feast. They consumed the endless rain of dead organic matter, the bodies of trilobites, corals, and plankton sinking from the dying surface world. And as they feasted, they breathed. But they did not exhale carbon dioxide. They exhaled methane, and they exhaled hydrogen sulfide. Methane, a super greenhouse gas, many times more potent than carbon dioxide at trapping heat. The planet, in its fever, had just created a new, more powerful fever. Hydrogen sulfide, the smell of rotten eggs, a gas so toxic that in high concentrations, it can cause instant death. This toxic gas did not stay in the water. It erupted from the poisoned oceans, pouring into the atmosphere. The air on land was no longer just an oven. It was a gas chamber. The creatures that had survived the heat now found their very breath was poison. The world was dying. The oceans, once blue, were likely a sick, oily, pinkish purple, the color of the new bacterial kings, a visual signal of a planet rotting alive. This is how you kill 96% of all life. You do not use one weapon. You create a cascade, a kill mechanism so complete that it attacks from every angle. You heat the world until it blisters. You suffocate the oceans until they stagnate. And then you unleash a new life form that exhales poison, turning the atmosphere itself into a toxic, unbreathable soup. The great dying was complete. The planet was silent. The crime scene was wiped clean, leaving behind almost nothing at all. Nothing, that is, except a ghost. The fire had burned itself out. The million-year eruption of the Siberian traps had finally slowed, sputtered, and fallen silent. The skies, no longer thick with sulfur and ash, began to clear. But the world was not saved, it was simply finished. What remained was the aftermath, a hollowed-out, sterilized planet. The lights were back on, but the house was empty. Welcome to the early Triassic. Welcome to the ghost world. This was not a world of recovery. It was a world of profound, echoing silence. Imagine standing on the supercontinent of Pangaea. The air is still unnaturally hot, thin and hazy. The great conifer forests that once defined the Permian are gone. They are not just burned, they are erased. The landscape is a vast, reddish-brown graveyard of dead, acidic soil, scoured by acid rain. There are no complex sounds. There is no birdsong, no complex insect hum. There is only the sound of a dry, hot wind whistling over dead plains and the faint, unsettling bubbling of methane still rising from stagnant, poisoned swamps. The oceans are no better. The magnificent three-dimensional reefs are dead, skeletal ruins smothered in a carpet of microbial sludge. The waters, once blue and teeming, are now a stagnant greenish purple. The great predators, the sea scorpions, the armored fish, the complex hunters, are gone. The trilobites are gone. 96% of the ocean's soul had been extinguished. This was a planet reset to its factory settings, a world ruled by bacteria and fungi. And yet, something did survive. In this empty, poisoned and suffocating world, a few lone vertebrates clung to life. These were not the kings of the old world. They were not the magnificent sail-backed predators. They were the disaster taxa, the specialists in survival. And one animal, above all others, defines this entire empty age. Its name is Lystrosaurus. We must erase from our minds any image of a hero, a chosen survivor. Lystrosaurus was not a magnificent beast. It was mundane, a creature about the size of a pig, with a squat, barrel-chested body and two short tusks. It had no sharp teeth, only a turtle-like beak for shearing at tough, fibrous vegetation. It was not fast. It was not smart. It was not impressive. So why did it survive when 96% of all other life failed? The answer is that Lystrosaurus was a masterpiece of mediocrity. It was a creature perfectly, beautifully adapted for the apocalypse. When the air turned to poison, it burrowed. It dug deep into the dead soil, hiding in the cooler, more stable air of its tunnels, waiting out the worst of the heat and the toxic gas. When the forests died, it adapted. Its simple beak was a tool for eating anything. It didn't need fresh leaves. It ate the dead, woody, silica-filled roots and dry, rotting stumps that were the only food left. It was a living garbage disposal. And its body, its physiology, was its secret weapon. Its barrel-chested shape suggests it had large, powerful and efficient lungs. In a new, thin, low-oxygen world, this creature could simply breathe better than its competitors. And so it inherited the Earth. This is the true calm chill of the ghost world. It is not just the emptiness, it is the monotony. For millions of years, if you were to walk across the entire supercontinent of Pangaea, from the South Pole to the North Pole, you would see almost nothing else. In some regions, Lystrosaurus fossils account for 90% of all vertebrate life found. It was a world of ... an ecological nightmare, a planet without a food web, just a single, lonely thread. A world populated by a single pig-sized, burrowing generalist, walking silently through the ruins of a dead kingdom, forever. This was not a quick recovery. This hollowed-out, single-species world lasted for 5 million years. Life was stuck, unable to rebuild. The stage was silent. The kings were dead. The ghosts of the old world were gone, replaced by this one, lone, shuffling survivor. But this emptiness, this vast ecological vacuum, was a blank canvas. And in that silence, a new seed of life was beginning to take root. The ghost world was a prison, but it was also a nursery for the next dynasty. A silent world is an unstable one. Life is not patient. It is an opportunist. An ecological vacuum is a power source, a void waiting to be filled, and the 5 million-year ghost world was the greatest vacuum in the planet's history. Lystrosaurus, the pig-sized burrowing garbage disposal, had inherited the Earth by default. It had survived the apocalypse simply by being the hardest thing to kill. It was the king of the ruins, but a kingdom of ruins cannot last. As the planet's chemistry slowly, agonizingly slowly, began to stabilize, the first faint glimmers of new life began to emerge. The long silence of the early Triassic was finally breaking. The stage was set for a new evolutionary war. The world was a failed state, a hollowed-out continent waiting for a new dynasty. And there were two great contenders, two rival philosophies of life vying to claim the empty throne. On one side were the synapsids. This was the old guard, our own distant lineage, the dynasty that had ruled the Permian before the fire came. Lystrosaurus was one of them, but so were its more advanced cousins, the cynodonts. These were creatures that were becoming something new. They were no longer sprawling, cold-blooded reptiles. They were small, fast, and burrowing. Their fossils show the first hints of mammal-like teeth, of complex jaws. It is almost certain they had fur. They had whiskers. They were almost certainly warm-blooded. They were the survivors of the old murdered aristocracy, hiding in the shadows of the ruins, trying to rebuild the world they had lost. They were our ancestors. But they were not alone. On the other side was a new challenger, a different, more ancient lineage that had also survived the fire, but with a different set of tools. These were the archosaurs, the ruling reptiles. This was the lineage that would, in time, produce crocodiles, pterosaurs, and the creatures that would define the next 150 million years of life, the dinosaurs. The Great Dying had not just been a filter of luck, it had been a filter of physiology. The new post-Permian world was a brutal place. It was hot, it was dry, and the air was still desperately low in oxygen. The archosaurs were built for this world. While our warm-blooded synapsid ancestors burned through energy and needed constant food, the archosaurs were models of cold-blooded efficiency. While our ancestors lost water with every breath, the archosaurs had scaly, waterproof skin and excreted waste as uric acid, saving every precious drop. And most importantly, they had better lungs, a more efficient bird-like respiratory system, a one-way flow of air that was far superior at extracting oxygen from the thin, poisonous atmosphere. The Triassic period was not a recovery. It was a war, a long 50-million-year war between these two great dynasties. It was a battle for the soul of the planet, the warm-blooded, furred and fast-breeding synapsids versus the cold-blooded, scaly and hyper-efficient archosaurs. For millions of years, the fight was a stalemate. Neither side could gain the upper hand. The world was divided. And then, just as the planet was finally beginning to heal, the universe pulled the rug out, again. The 50-million-year war had reached a fragile stalemate. The world of the late Triassic was not a quiet, empty planet. It was full. It was a bizarre, violent, and experimental landscape. The two great dynasties, the synapsids and the archosaurs, had carved the globe into territories of fur and scale. Our own synapsid ancestors, the cynodonts, were not the dominant force. They had been pushed into the shadows of the world. They were small, nocturnal and fur-covered, hiding in burrows. They were living in the margins, surviving. The ruling dynasty was the archosaurs, but even this family was split. In one corner were the first true dinosaurs, small, fast, bipedal, and relatively insignificant. They were not the kings. They were the jackals of this new world, darting through the undergrowth, agile and opportunistic. The true rulers, the apex predators of the Triassic, were their cousins, creatures like the Rauisuchians. These were the real monsters, giant, four-legged, crocodile-like hunters that ruled the land with terrifying power. They were the lions of their age. The planet belonged to them. The game was set. The players were on the board. The rules were established. And then, just as life had finally found its footing after the Great Dying, the planet flipped the table. This is the fourth of the Big Five, the Triassic-Jurassic extinction. This was not an indiscriminate carpet-bombing event like the Permian fire. This was a selective assassin, a professional hit. When the dust settled, the victims were not random. The great Rauisuchians, the apex predators, were gone. The large, sprawling crocodile-line competitors, erased. The last of the large, dominant synapsids, our relatives who had tried to reclaim the world, wiped out. The filter had, with terrifying precision, surgically removed the dominant life forms on the planet. But who was spared? Our tiny, furred, burrowing synapsid ancestors, hiding in the dark, were largely untouched. And the small, fast, bipedal dinosaurs, they sailed right through the catastrophe. This was not a random filter. This was a coronation. This was the event that handed the keys to the kingdom to the dinosaurs. It did not make them superior. It did not make them stronger. It simply, brutally, and efficiently murdered all of their competition. It cleared the throne room, leaving the planet empty once again. But this time, it was an emptiness that only one group was poised to fill. The age of the dinosaurs was about to truly begin. But what kind of killer is so precise? What weapon kills the kings but spares the subjects? The clues were not in the sky, they were in the ground. The planet was, once again, tearing itself apart. The question is, what kind of weapon kills with such precision? What kind of catastrophe murders the kings but spares the jackals? The answer was not a bullet from space. The answer was a bomb ticking deep within the Earth. We must remember the stage, the supercontinent of Pangaea. For 100 million years, this single, colossal landmass had been the reality of the planet. It was a world of vast interiors, of profound stability, and of shared ecosystems. But this stability was a curse, a landmass that large acts as a giant insulating blanket. It traps the planet's internal heat. Deep beneath the crust, in the Earth's molten mantle, a plume of unimaginable heat was gathering. It was a superplume, a column of molten rock rising from the core, pushing upwards directly against the underside of the supercontinent. The pressure was building. The crust was being heated from below. It was being stretched. It was growing thin. And then, 201 million years ago, it tore. This was not a gentle separation. This was a violent, continental-scale rupture, a wound that would one day become the Atlantic Ocean. As the continents of what would become North America and Africa were ripped apart, the planet did not just bleed lava, it hemorrhaged. This is the chief suspect, the Central Atlantic Magmatic Province, or CAMP. We have seen this before. This is another traps event, another flood basalt like the Siberian traps that caused the Great Dying. But this was a different kind of killer. The Siberian traps were a million-year siege, a slow, suffocating flood of gas and lava. Camp was an execution. It was not a slow leak. It was a series of violent, catastrophic, shotgun-like pulses. For hundreds of thousands of years, the planet was seized by paroxysms, by violent fits. Massive, continent-spanning fissures would rip open, releasing an unimaginable torrent of lava and gas, and then fall silent. And then, a few thousand years later, a new fissure would rip open, and it would happen all again. This pulsing nature was the key to its selective killing. Each pulse was a two-punch attack. First, the fire, the release of sulfur dioxide. This gas shot into the atmosphere, creating a thick, hazy veil that blocked the sun, plunging the planet into a sudden, deep, brutal volcanic winter. Temperatures would have plummeted globally in a matter of months. Then, the heat, the release of carbon dioxide. After the sulfur rained out as acid, the CO2 remained. And it remained for centuries. This gas, in immense volume, triggered a hypothermal event, a rapid, violent runaway greenhouse effect, just as we saw in the Permian. This was the kill mechanism, chaos. The planet was thrown onto a violent geological seesaw, a world of climate whiplash, A century of freezing darkness, followed by 1,000 years of suffocating heat, followed by another snap freeze, followed by another furnace. So who dies in a world of pure chaos? The specialists, the kings. The great Rauisuchians, the apex predators, were large and cold-blooded. They were adapted to the stable, hot world of the Triassic. They could not survive a sudden, deep freeze. Their food chains vanished overnight. They were too large to hide. They froze. The large synapsids, our relatives, were also specialists, unable to cope with wild, unpredictable swings. They starved. But who survives? The generalists, the adaptable. Our tiny, burrowing ancestors, the first true mammals, survived by hiding. They lived underground in insulated tunnels, buffering themselves from the violent swings of the outside world. And the dinosaurs, they were already small, they were already fast, and they may have had a secret weapon, a high metabolism, perhaps even primitive feathers. In a world that suddenly plunged into cold, their warm-blooded or proto-warm-blooded bodies gave them the edge. They could weather the cold snaps that killed their larger, cold-blooded archosaur rivals. This filter was not an executioner. It was a revolutionary. It tore down the old regime. It selected against size and specialization, and for adaptability and resilience. When the gas finally cleared and the climate stabilized, the dinosaurs looked around. The throne room was empty. The giants that had hunted them, the competitors that had kept them small and in the shadows, were gone. The planet was theirs. The throne room was empty. The dinosaurs, once the small, agile opportunists, had inherited the Earth, and they ruled. Their reign was not short. It was not a brief, passing dynasty. They commanded this planet for 165 million years. It is a span of time so vast, so complete, that it is almost impossible to comprehend. Our own entire human story is a rounding error in their timeline. They diversified into a pantheon of gods. They became the largest creatures to ever walk the land, the sauropods, living mountains of flesh that moved in great, earth-shaking herds. They became the apex predators, the Tyrannosaurus rex, a 40-foot, 9-ton hunter, a walking engine of crushing bone. They became the Triceratops, a living fortress of shield and horn. They filled every niche, from the rivers to the skies, in a stable, complex, and wildly successful global empire. This was their world. It did not belong to us. It belonged to them. And then came the last day of that empire. It was, by all accounts, a perfectly normal day in the late Cretaceous, a Tuesday afternoon, 66 million years ago. In the heart of what is now North America, a Triceratops was browsing on low-growing ferns. The air was warm, humid. The sky was blue. There was no warning. There was no shadow. Because the killer was not coming from the horizon, it was coming from above, and it was moving faster than the sound of its own arrival. For months, perhaps for years, it had been a silent traveler in the dark, a piece of rock, a 10-kilometer-wide fragment of an ancient asteroid, knocked loose from its orbit, falling toward the sun. It crossed the orbit of Mars. It swept past the moon. It was a silent, cold, and indifferent piece of cosmic geology. And then it found our planet. In the final few seconds, as it struck the upper atmosphere, the air itself became the weapon. The compression of the air in front of the asteroid heated to a temperature hotter than the surface of the sun. The sky was torn open. It struck the shallow, tropical seas of what is now the Yucatan Peninsula. We must not imagine this as an explosion. That word is too small, too familiar. This was not a bang. This was a geological event. This was the planet being wounded. In the instant of impact, the asteroid and the crust of the Earth beneath it ceased to exist as solid matter. They were vaporized. A 10-kilometer-wide object moving 20 times the speed of a rifle bullet unleashed an energy equivalent to more than 1 billion Hiroshima bombs. The planet rang like a bell. A flash of impossible, blinding light would have been the first thing. A burst of thermal energy so intense it scorched the continents, instantly igniting forests thousands of kilometers away. A crater 180 kilometers wide was blasted into the Earth in seconds. The ocean itself was vaporized, blown back to expose the molten rock of the mantle beneath. But the most spectacular and most deadly event was the ejecta. The force of the impact blasted a plume of molten rock, vaporized asteroid and superheated dust upwards. It was punched through the atmosphere and into the cold vacuum of space. For a few brief, terrifying minutes, the Earth had a ring of its own fire. And then, that material, pulled by the planet's gravity, began to fall back. This was not a gentle rain of dust. This was a global storm of red-hot glass. As these tiny beads of molten rock, called spherules, re-entered the atmosphere all around the globe, they heated the sky to a furnace. The air itself became an oven. The sky was no longer blue. It was a glowing, red and radiant ceiling of fire. Any living creature, any dinosaur, any plant exposed on the surface of the planet was cooked alive in minutes. The great global forests of the Cretaceous world all caught fire at the same time. And this biblical, unimaginable, planet-sterilizing inferno was not the kill mechanism. It was just the beginning. The true killer was not the fire. It was the winter that the fire would bring. The sky was on fire. The air itself had become an oven. And then, as the last of the red-hot glass rained down, the firestorm subsided. But the world was not saved. It was condemned. The true killer was not the fire. The true killer was the ash. We must remember the mechanics of the impact. The asteroid did not just hit the Earth. It vaporized it. 10 kilometers of asteroid and 100 kilometers of the Earth's crust beneath it were turned into a superheated plume of pulverized rock, dust and sulfur. This plume blasted upwards with unimaginable force, punched through the atmosphere and into the cold, silent vacuum of the stratosphere, and it stayed there. It did not fall back. It spread. A cloud of debris so vast, so thick, that it fanned out from the impact site, carried by high-altitude winds, until it merged with itself on the other side of the planet. It formed a perfect, seamless, impenetrable shroud, a wall of darkness. The sun was gone. We must not imagine this as a dimming, not as a cloudy day. This was an absolute, total physical absence of light, a darkness as complete as the bottom of the Mariana Trench, a darkness that fell over the entire globe, from pole to pole, at the same time. And with the darkness came the cold. The firestorm had been a brief, searing heat. But now, with the sun's warmth completely blocked, the planet's temperature plunged. This was the impact winter. The ground, still smoldering from the fires, was now subjected to a deep, agonizing freeze. The oceans, their surfaces still simmering, looked up at a black, frozen sky. The world was plunged from a furnace into a freezer in a matter of days. And in this new world of cold and dark, the true dying began. The first victim was the very engine of life itself, photosynthesis. The plants, the phytoplankton in the ocean, the great trees on land, they could no longer eat the sun. The engine of the entire planet was, in an instant, turned off. In the oceans, the plankton were the first to die. The base of the entire marine food web simply vanished. This was a cascade of starvation. The tiny creatures that ate the plankton died. The ammonites, the great coiled-shelled survivors of 3 previous mass extinctions, died. The great mosasaurs, the 50-foot reptilian tyrants of the sea, starved. The oceans, almost untouched by the impact itself, became a vast, dark, silent graveyard. On land, the scene was even more gruesome. The herbivores that had survived the firestorm, the triceratops that had perhaps huddled in a deep, rocky ravine, the Edmontosaurus that had sheltered in a cave, now emerged from their hiding places. They emerged into a world they could not recognize, a world of total darkness, a world of freezing cold, and a world with no food. The plants that had not burned were now dead or dying in the dark, their leaves black and withered. The great herds starved first, their massive bodies a liability. They were the last great meal. And then the king died. The Tyrannosaurus rex, the apex predator, had survived the impact. It had survived the firestorm. It was a robust, powerful animal, but it was now a king with no subjects, a hunter in a foodless world. Its death was not glorious. It was not a battle. It was a slow, agonizing, anticlimactic starvation, alone, in the cold and the dark. This is how you kill the dinosaurs, not with a single violent blow, but with a slow, silent, absolute starvation. You turn off the sun. But the planet, in its terrible ingenuity, had one last weapon. The sulfur from the vaporized rock mixed with the water in the atmosphere. It began to fall as a corrosive, planet-wide acid rain, turning the dark, dying oceans and the freshwater lakes into a toxic, acidic soup. The world was now dark, cold, starving, and acidic. The mystery, then, is not what killed the dinosaurs. The mystery is how anything survived at all. The case seems closed. It is perhaps the most satisfying, most complete, and most cinematic solution to any mystery in deep time. We have the murder weapon, the 10-kilometer-wide asteroid. We have the bullet casing, a thin, dark global layer of soot and exotic metal, iridium, left by the vaporized asteroid, found in the exact right layer of rock. We even have the body, the 180-kilometer-wide scar of the Chicxulub crater, buried deep beneath the shallow waters of the Yucatan Peninsula. The gun, the bullet, and the wound. Case closed. And for decades, this was the story we told ourselves. A story of terrible, cosmic bad luck. A single, random Tuesday afternoon that ended a 150-million-year empire. And yet, in the quiet halls of paleontology, a debate has always raged. A nagging, persistent, uncomfortable question that complicates this clean, simple narrative. Was it really that simple? Was the asteroid a lone gunman, striking a perfectly healthy, vibrant, unsuspecting world at the peak of its glory? Or was it an opportunist, just the final catastrophic theatrical blow to a world that was already sick? A planet already weakened, already suffering, already teetering on the brink of collapse? To find the answer to that mystery, we must travel. We must leave the impact crater in Mexico and journey to the other side of the globe, to what is now the continent of India. And we must look at the rock layers beneath the iridium-laced signature of the impact, because 66 million years ago, the Earth was already bleeding. The second suspect has a name, the Deccan Traps. We have seen this killer before. The same ancient enemy that caused the Great Dying. Another flood basalt. Another vast, open, continental-scale wound in the planet's crust, where the Earth's mantle was hemorrhaging fire. It was not a single mountain. It was a sprawling volcanic province that would eventually erupt to cover an area of 500,000 square kilometers. A flow of lava so vast it would bury half of India under a mile of new black rock. And here is the core of the mystery, the part that chills the blood. The timing. The eruptions did not start with the asteroid. They began, it is estimated, 300,000 years before the rock ever hit the water. For 300,000 years before that final terrible Tuesday, the planet was already in the grip of a catastrophe. The Deccan Traps had been pumping a steady, relentless, toxic flood of carbon dioxide and sulfur dioxide into the atmosphere. The planet, when the asteroid arrived, was not healthy. It was already sick. It had a fever. The climate was already becoming unstable. The oceans were already becoming more acidic from the sulfur. The ecosystems were already under profound, long-term stress. The dinosaurs were not living in a stable paradise. They were living in a planetary hothouse, their food chains already beginning to fray. This was not a healthy victim. This was a patient with a pre-existing condition, a world already weakened by a slow-acting poison from within, now facing a shotgun blast from without. This realization changes the entire story. It is no longer a simple case of murder, it is a conspiracy. So, what is the verdict? We stand before a 66-million-year-old crime scene with two killers. On one side, we have the poison, the Deccan traps, a slow-acting internal insidious enemy, a million-year siege of sulfur and carbon, patiently choking the world, acidifying the oceans, poisoning the air. It was a chronic illness, a planetary fever that had gripped the globe long before the final catastrophe. On the other side, we have the gun, the Chicxulub impactor, a fast, brutal external force, a sudden, unimaginable kinetic shock that unleashed a global firestorm, a wall of darkness, and a deep, impact-driven freeze. For decades, science has tried to pin the murder on one of these culprits. It was the volcanoes. No, it was the asteroid. But the evidence, written in the dark, silent layers of the rock, tells a more complex and far more terrible story. The truth is, it was not one or the other. It was both. It was the single worst day, preceded by the single worst millennium in the history of the planet. It was a conspiracy of chance, a perfect, terrible, unsurvivable storm. The Deccan traps were the body blow, the long, grueling fight that exhausted the champion. For 300,000 years, the volcanoes had been weakening the entire global ecosystem. The world's immune system was compromised. The oceans were acidic, their food chains already stressed. The great herds on land were living in a world of constant, unpredictable climate whiplash. Decades of heat, followed by decades of sulphurous cold. Life was harder. The dinosaurs were not living in a paradise. They were survivors, clinging to a world that was becoming increasingly hostile. The entire magnificent structure of their 150-million-year empire was, by this point, brittle. And then, the asteroid struck. This was the second punch, the knockout blow to the head. If the asteroid had struck a healthy, stable, vibrant world, would it have been a Big Five extinction? Perhaps, but it did not strike a healthy world. It struck a world already on its knees, weakened by the poison from within. The volcanoes had weakened the food chains from the top down. The asteroid attacked from the bottom up. The Deccan traps stressed the large herbivores. The asteroid erased their food source entirely by turning off the sun. The Deccan traps made the oceans acidic. The asteroid, with its wall of darkness, starved those oceans in months. This is the verdict. It was a 1-2 punch. The planet's internal sickness, the great volcanoes, had held the victim down, and the external shock, the rock from space, delivered the final, fatal, decisive blow. The dinosaurs, the great kings, the apex rulers, were doomed by their very success. They were large. They were at the top of a long, complex food chain, and when that food chain was attacked simultaneously from the top, the middle, and the bottom, it did not bend, it shattered. The reign of the dinosaurs was over. The great filter had slammed shut, and in the cold, dark, silent, acidic ruins of their fallen empire, a new kind of creature, a tiny, furred, shaking survivor, was about to see the light. The fire has passed. The long black winter has begun. The oceans are acidic, and the land is a frozen, silent graveyard of giants. The filter has slammed shut. So, who is left? Who punches through? In a world of total systemic collapse, what does it mean to be a survivor? This was not a test of strength. Strength was a liability. The Tyrannosaurus, the pinnacle of power, was dead, starved by the very appetite that made it a king. This was not a test of specialization. Specialization was a death sentence. The Triceratops, a perfect herbivore, was dead, its specific food source erased by the darkness. This was a planetary lottery, a cosmic reset, and the winning tickets were not held by the kings, or the strong, or the specialized. The winning tickets were held by the humble, the small, the overlooked. The survivors were the creatures that lived in the cracks of the old world. The first winning ticket was size. In a world with no food, the greatest advantage was to need less of it. A 9-ton T-Rex needed hundreds of pounds of meat every day. The creatures that survived were the ones that could live for a week on a single rotting fungus or a handful of dormant insects. The second winning ticket was location. The surface of the planet had become an uninhabitable hell, a furnace, then a freezer, then a bath of acid. The survivors were the creatures that were not on the surface. They were under it, the burrowers, the creatures that had already made their homes in the cool, stable, insulated darkness of the soil. They huddled in their tunnels as the firestorm raged above. They slept as the deep freeze locked the world. They were shielded from the worst of the chaos by a simple, profound layer of dirt. The third winning ticket was diet. The specialists died first. The survivors were the generalists, the creatures that did not care what they ate. The garbage disposals of the Cretaceous, animals that could derive sustenance from the dead, the rotting leaves, the wood, the fungi, the insects in the soil. And the fourth winning ticket, a slow metabolism. The true masters of survival were the creatures that could simply wait. The crocodiles, the turtles, the amphibians, creatures that could slow their hearts, enter a state of deep, cold torpor and turn off for months or even years, waiting for the sun to return. Now, let us look at our own distant ancestor. For 150 million years, this creature had been living a life of quiet desperation. A small, furred, nocturnal animal, the size of a shrew. It had spent its entire evolutionary existence scurrying in the shadows of the dinosaurs, hiding in burrows, its evolution suppressed by a dynasty of giants. It held all the winning tickets. It was small. It needed almost no food. It was a burrower, already underground when the sky fell. It was a generalist, eating insects, roots, seeds, and the dead. And it had one final, secret advantage. It was warm-blooded. In the long, dark, impact winter, this was the key. While the cold-blooded reptiles froze solid, our tiny ancestor was a living furnace. In the safety of its insulated burrow, it could burn its own internal fuel, stay active, stay warm, and wait for the world to return. The filter had, in one violent, catastrophic day, done something that 150 million years of evolution could not. It had killed the giants. It had, in a single moment, erased the tyrants, the rulers, the competitors. The age of reptiles was over. The 150 million year-long suppression of the mammals was finished. As the skies finally, slowly, began to clear, that small, furred, shaking survivor, our ancestor, crept out of its burrow. It did not find a graveyard. It found an inheritance. It found an empty, silent, waiting world. The age of mammals was about to begin. The darkness had passed. The sun, after a long, cold winter, had returned. Our ancestors inherited a silent, empty, broken world. And for the next 66 million years, life did what it always does. It rebuilt. This new age, the Cenozoic, was our age, the age of mammals. The small, shrew-like survivors of the Great Filter diversified into a new pantheon of life. They left their burrows and claimed the empty thrones of the dinosaurs. They became the Indricotherium, a 20-ton hornless rhinoceros, the largest land mammal that has ever lived. They became the whales, masters of the deep ocean, returning to the waters their distant ancestors had once crawled from. They became the saber-toothed cats, a new kind of apex predator. Evolution, in its relentless, patient, beautiful artistry, had refilled the world. The planet was loud again. It was complex. It was stable. And then, in a tiny, insignificant corner of that world, in the grasslands of Africa, one of the survivors of this new age, a primate, began to experiment. It was not a specialist in strength or speed or armor. It was a specialist in thought. It developed a new kind of weapon, a weapon more powerful than the claws of a T-Rex, more transformative than the poison of the Permian seas. It developed consciousness. It developed cooperation. and it developed technology. This, of course, is us. And with our arrival, we have triggered a new event. The geological strata of our own time are once again recording a catastrophic disappearance of life. The background pulse of extinction has stopped, and a new, violent spasm has begun. We are now living in the middle of the sixth mass extinction. But this one is different. For 300 million years, the Big Five have been our case studies. We have sifted through their ancient, cold, silent crime scenes. We have hunted for their mysterious killers. We hunted for the cosmic trigger of the Ordovician. We hunted for the green, suffocating killer of the Devonian. We hunted for the million-year-long fever of the Siberian traps. We hunted for the continental chaos of the Triassic. We hunted for the conspiracy of rock and fire that ended the Cretaceous. These were all mysteries, vast, impersonal, geological or cosmic forces. Dumb killers. An asteroid does not hate the dinosaurs. A volcano does not have a motive. The Sixth Extinction is not a mystery. We know the killer. We have the fingerprints. We have the weapon. We have the motive. The killer is the conscious, intelligent, self-aware species that is currently documenting the crime. We are the filter. And this is the final and most profound, unsolved mystery of them all. The mystery of the Ordovician was what caused the ice. The mystery of the Devonian was why the oceans suffocated. The mystery of the Sixth Extinction is psychological. The mystery is, why doesn't the killer stop? Why does a species that is intelligent enough to read the 4-billion-year-old crime scene, a species that can see the black anoxic rock of the Devonian, that can model the runaway greenhouse of the Permian, that can find the iridium layer from the asteroid? Why does that species, with all that knowledge, all that foresight, choose to pull the same familiar ancient levers? This is the real great filter, not a rock from space, not a flood of lava. The real filter is whether a species can survive its own intelligence. We have sifted through the ashes of 4 billion years. We have stood in the silent, frozen dark of the Ordovician. We have breathed the poisoned, suffocating air of the Devonian twilight. We have walked the hot, empty, haunted plains of the ghost world, and we have huddled in the long, black, acidic winter of the final impact. We have been investigating a series of crimes, hunting for killers, searching for motives, weighing the evidence of cosmic rays, volcanic poisons, and rocks falling from a merciless sky. But perhaps we have been looking at this story backwards. We have been obsessed with the dying, but the true, profound, far more staggering mystery of this planet is the surviving. The story of the fossil record is not a story of tragedy. It is a story of miracles. Life itself, in its most humble form, is almost impossible to kill. The planet has been boiled, poisoned, frozen, battered, and gassed. And the bacteria, the archaea, the single-celled engines of this world endured. They never left. The planet's fundamental pulse never truly stopped. But this complex, beautiful, intricate, noisy world, the world of forests, of reefs, of giant armored fish, of sailing synapsids, of tyrant dinosaurs, and of conscious thinking primates, this is not the rule. This is the fragile, fleeting, spectacular exception. This is the real lesson of the filters. They are not an interruption of the story. They are the story. The default state of this planet is not a complex, noisy biosphere. The default state is a quiet, microbial one. The default state is silence. We are living in a brief, privileged, lucky interlude, a warm, stable moment purchased for us by the 66-million-year-old death of the dinosaurs. We are an experiment painted onto a canvas defined by its emptiness. This is the true silence of the Earth. It is not an absence of life. It is the vast, deep geological foundation upon which these brief, bright, impossible towers of complexity are built. And the fossils, those whispers in the stone we have been chasing, are the only signal we have. They are a faint, broken transmission, a warning perhaps, a message from those other lost, complex, noisy worlds that came before us. They are a reminder that the game of complexity is a high-stakes one, a reminder that strength and power and dominance are temporary, a reminder that the house, the vast, impersonal, patient casino of physics and chemistry, almost always wins. We are the children of the lottery winners, the descendants of the tiny, furred, terrified creature that inherited a graveyard and called it an empire. And as we drift off to sleep, here in our own brief, warm, noisy room, we are, ourselves, just another whisper. Another signal waiting for its turn to be recorded, and perhaps one day discovered in the long, patient, silent stone.